Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so that you can help your kids with math. And today we're discussing how to find the volume of a pyramid. So, the way I had learned it, first you need to identify that you are, in fact, dealing with a pyramid. And you could tell this is a pyramid because we've got a rectangular base down here, and then the other faces are triangles. So that's what makes this a pyramid. You can think of like the pyramids of Egypt. So our equation, which is something I just memorized growing up, and I'll be honest, this equation had slipped my mind. I had to look it up to remind myself. It's the volume is length times width times height divided by 3. So I would just plug in to find the volume of this particular pyramid. So the length and the width are the two dimensions of the rectangular base. So I'd say, okay, that's 5 times 6. The height is the height of the pyramid, which is given as 4. And this is all divided by 3. So 6 times 5 is 30. 30 times 4 is 120 over 3. And if I do 120 over 3, sorry, John, I'm going to ooze into your part of the slides. That's going to give me 40. And then I can't forget my units of measure. It's in inches, so it's going to be inches cubed. Okay, John, tell us a new approach we should think about.
So, in continuing with our previous discussions of finding volume of other things like um, cylinders and cones and whatnot, we often look at the base of the shape. Something that differentiates a pyramid from a prism is the fact that it goes up to a tip, right? Even though there's a rectangular base here, it just goes upwards. But in either case, a prism would have two bases that are parallel from each other, both rectangles or triangles or whatever. But a pyramid only has one base. So because of that, our formula changes very slightly. Last time we talked about using the formula BH, where B stood for area of the base, whatever the base happened to be. So it could have been a triangle, it could have been a rectangle, it could have been a square, etc. But because we do go upward on a slant, we don't go straight up. We have to make an adjustment for that because we don't get the full volume associated with a prism. Like we did last time with our prism video, we get less than it because we're going up in a slanted manner. And a lot of schools do the whole thing with dumping water or rice to show how many of these pyramids fill up a prism, and it turns out that if you take 3 pyramids with the same base and height, that can fill up a prism of the same base area and height. So for that reason, we say that the volume of a pyramid is 1/3 the area of the base times the height. And in this problem, when we look at the pyramid, we see that the base is a rectangle. So we would think of it as 1/3 of 5 times 6, the area of the base, but then times the height. The height's the vertical part. It goes straight down from the tip of the pyramid to the center of the rectangle at a right angle, and that part is 4. So the math is exactly the same. And due to the associated property, we can group these however we want. So if I did the base area as 30, my math will work out to be 1/3 of 30, which is 10, and then 10 times 4, which is 40. This is just another equivalent way to do the same thing.
That's great, John. I had 2 thoughts listening to your explanation. One was so basically, is my understanding correct that if a 3D object goes into a tip like that, then it's basically either going to be a cone or a pyramid? And because it's a rectangle or square at the bottom, that would be a pyramid. If it was a circle, it would be a cone. Is that correct?
Exactly. So we call the cone, a cone has a special name because its base is a circle. Just like when we talk about prisms, there's triangular prisms, rectangular prisms. But when the prism happens to have a circle as its set of parallel bases, we call it a cylinder. So we just give special names to 3D shapes that have circles as their base.
I see. Okay, so when we see a point, we should think pyramid or
Yep.
cone. But I think cone is very easy to recognize.
Correct. We all like ice cream.
Exactly. And then the other thought I had was this 1/3. It kind of reminds me of how, like in our house, we have rooms on the second floor, and they have kind of lower ceilings towards the edge, and you have to kind of remember to kind of hunch over if you walk that way. And so, because the pyramid is going to a point, you kind of have to remember to take that into account, with the 1/3 in the formula. So, I'm going to keep that in mind, and I'm going to do an example.
All right, let's try one out. Okay.
Okay, so we have another pyramid here. We see this point at the top, and we've got a rectangular base, so we know it's a pyramid. And I'm asked to find the volume. So I'm going to say, okay, the volume. Normally it would be the area of the base times the height. Because we've got a pyramid here, we need that 1/3 there. So then my base is a rectangle, which is 10 feet by 9 feet. So I'm going to say, okay, my area will be 10 by 9. And then my height of the pyramid is 2 feet. So I've got 1/3 times 90 times 2. And 1/3 times 90 gives me 30 times 2. And 30 times 2 gives me 60. And this is a slightly larger pyramid. We're in feet now. So it's cubic feet. All right, John, I really like that.
Yeah, and I think it just reinforces the idea that when we talk about volume, that it's a collection of slices. And if a student took slices of a pyramid this way, it's just a stack of rectangles that ultimately, each rectangle is getting smaller and smaller in area. But if we just stack them all one on top of the other, we get the total shape. And that kind of reasoning is important as they get up into calculus, because they'll be working with area and volume much later on in more detail. So to get them used to thinking about volume as an accumulated area, type of thing, I think that's a good base understanding to have from a young age.
Wonderful. I love it. This is great. Okay, thank you very much. Thank you all for watching. We're Math Videos for Parents. If you have any topics you'd like us to cover, please don't hesitate to reach out. We really look forward to hearing from you. And you can follow us on Facebook at Math Videos for Parents and also on YouTube. Thanks so much.
Have a good weekend.